In this video we're going to be looking at Hess's Law calculations for A-level chemistry. Now Hess's Law states that the change of enthalpy in a chemical reaction is independent of the pathway between the initial and final states. Now what on earth does that mean? So let's say you've got A and B reacting to give you C and D, and let's say the enthalpy change for the first step is 300 kilojoules per mole. If you did the exact same reaction but in 4 steps, the enthalpy change should be exactly the same, which is 300 kilojoules per mole. And this is what Hess's Law is trying to state, that whether you do a reaction in 1 step or an infinite number of steps, the overall enthalpy change will be the same. Now why would this be useful? So let's say your direct route is very difficult to measure experimentally. You could then work out the sum of the intermediate routes to then figure out what your direct route would be, because they are both equivalent. I'm going to show you a worked example using Hess's Law. We're going to apply it to this exam question about the extraction of manganese, and the question has already given you the standard enthalpy of formation values in this table over here. And we're going to start off by first of all drawing a box with our elements, and I'm going to draw an arrow from this box to show that it's forming my compounds. Notice that I've missed out manganese because the standard enthalpy of formation for elements in their standard states is always going to be 0. The next thing I have to do is to plug in my values. Notice how I've got 3 times minus 111 for carbon monoxide, because there are 3 moles of carbon monoxide, and the same thing here for carbon dioxide. We are trying to work out the enthalpy change for this reaction. So we've got route A, the direct route, but there's no values here, so we can't actually go through there. However, we can go through route B, which has these values over here. So if we take the sum of these values, we should get our enthalpy change for this reaction. Now a key thing to bear in mind is that whenever you reverse an arrow, so this minus 971 becomes plus 971. We then add that to 3 times plus 111. Add that to 3 times minus 394. It's going to stay a minus number because you're going with the arrow. Put that into your calculator and you should get plus 122 kilojoules per mole. So here's a second exam question. It's slightly different to the previous one because you're now dealing with the standard enthalpy of combustion, and what this question wants you to do is to work out the enthalpy of formation of this compound maleic acid. They've given you the standard enthalpy of combustion, and combustion is when you react 1 mole of your substance completely with oxygen. So carbon is going to form carbon dioxide, hydrogen is going to form water, and our compound maleic acid will form both water and carbon dioxide. So I can show this by drawing an arrow from our substances into this box, which shows our combustion products. And we are trying to work out this enthalpy change, so route A, but there's no values there, so we are forced to go through route B and take into account these values over here. So once again, if you go with the arrows, you keep the operation the same. If you go against the arrows, you just reverse the operation. So you should get 4 times minus 393.5 added to 2 times minus 285.8 added to plus 1356, and that should give you minus 789.6 kilojoules per mole. So that is the end of the video. Thank you very much for watching. I hope you found the video useful. If you did, please leave a comment and subscribe. I've also left a link in the description box to some exam questions so you can practice this further. The answers are also included.